Okay, so we're looking at ancient Roman numeration, or Roman numerals as we usually know them by. Even though this is an ancient form of numeration that's not used for any practical purposes nowadays, most of us are still familiar with it. Roman numerals are used a lot of the time, mostly for aesthetic purposes. One thing that comes to mind is the Super Bowl. You know, when we talk about which Super Bowl we're having, we usually represent that number with Roman numerals. There's lots of other places that we see them. But this was the way that the ancient Romans kept track of numbers, or represented numbers symbolically during that time. So we're going to learn this system. It's got some similarities to the Egyptian numeration system in the sense that we're grouping things in powers of 10, but then they go a little bit further and they also go kind of in between the tens and find or come up with symbols for 5, 50, 500, things like that. Okay, now Roman numerals also follow a couple of conventions that you don't really see elsewhere, and it takes a little bit of practice to get used to these, but we're going to define them here and then take a look at an example. So the two conventions that we use with Roman numerals are called the subtractive feature and the multiplicative feature. The subtractive feature is a technique that's supposed to prevent too much repetition of the symbols, and it's what happens when we have a symbol for a smaller number preceding a symbol for representing a larger number. So here's kind of what I mean. If I go back to very beginning when I gave this example of a Hindu Arabic number, 734. As we go from left to right, we're starting with symbols that represent larger powers of 10 and working our way down to smaller powers of 10. 100, which is the place value here, is larger than 10, which is the place value that comes after it. Roman numerals generally use the same thing. You know, the tens place is going to be followed by the ones place, you know, or the thousands place will be followed by the hundreds place. We want the place values to be getting smaller as we go from left to right. The subtractive feature is the exception to that rule. If you ever see that happening in reverse order, a place value that's smaller appearing to the left of a place value that's larger, well, that means that we do subtraction there. So here's an example. Looking at our chart or our table, this capital V represents 5, this capital I represents 1. If you have the smaller place value, the I, showing up before the larger place value, V, so it looks like IV, then what we're meant to do there is subtract that smaller number from the larger number. Take 1 from 5. This represents 4. Okay? If I do it in reverse order, so the larger place value followed by the smaller one, then no subtraction takes place. This represents a 5 and a 1, which totals to 6. Okay? That subtractive feature is only ever used in specific cases. So up here we had 1 preceding a 5, but if 1 precedes a 10, that also means that we're doing that subtractive feature. But these are the only two numbers that can be preceded by a 1. L is 50, C is 100, so 50 and 100 can both be preceded by a 10, but no other numbers can be preceded by a 10. And then D and M, this is 500 and 1,000. Those can be preceded by a C, which is a 100, but no other numbers can be preceded by a C, a 100. Okay, so again, we'll look at some examples in a moment. Next is the multiplicative feature. So if you notice here, we only have symbols going as high as representing 1,000. Now the ancient Romans did need numbers larger than 1,000. They weren't just keeping track of sheep back then. They were, for that time, an advanced civilization. They had census that they would take. They had a big population. They needed numbers larger than this. But you notice there's no symbol for for 50,000 or 10,000 or 500,000 or a million or anything like that. So where did they get those numbers from? Well, what they would do is they'd add additional notation to the symbols they already had in the form of little bars that would go over the top. So that's called the multiplicative feature, and here's how we would interpret that. If you had a bar over any numeral, what that implied is that we were multiplying that numeral by 1,000. If we had a double bar over any numeral, that implied that we were multiplying by 1,000,000. So let me see if we can represent some of these Roman numerals here in Hindu Arabic. Okay, so let's start by going from left to right. M, D. What is M? Remember, M is 1,000. So I'm going to have a 1,000 here. D. What is D? That's 500. And you need to be careful not to immediately write 5 here. In this case, it's not going to work. And if you think about why, you have symbols for both 500 and for 100 here. And if you have, say, D followed by C, that's 500 and 100, that's actually going to be 600. If I wrote a 5 here, I'd be putting the wrong number in that place value. So again, that's where you need to be careful to not do that. In this case, though, it actually isn't going to be an issue. Notice I don't have any C's that immediately follow that D right there. So D is 500. And if we continue moving on, this is where that subtractive feature makes an appearance. I have an X, which is a 10, followed by a C, which is a 100. Notice we're no longer going from larger place values to smaller place values, or larger numbers to smaller numbers. It seems flip-flopped here. So rather than say 10 and then 100, we look at these two symbols together and apply our subtractive feature, meaning we take the smaller one from the larger one. What is 100 minus 10? Well, that would be 90. So that means in our tens place, we actually have a 9 here, representing 90. Now what's left? 5, 1, 1. 5 plus 1 plus 1, that's 7. So I have a 7 here, 1,597. Notice it's a little trickier than working with Egyptian numeration. The trade-off is that there's less to write. So this exact same number in Egyptian numeration would require much more repetition with my symbols. I'd have to do 7 strokes, 9 heel bones. I'd have to do 5 scrolls and then 1 of those lotus flowers. Whereas here, all I needed was 7 simple little symbols that I had to write out. But again, the trade-off is that it's a little bit trickier to know how to read this number. Okay, let's try another one. This one didn't print very well for me. This is supposed to be a double bar right here. So I'm just going to draw in that second bar so it's a little clearer. What is this number? Well, the 5, that's what V represents, has a double bar over it. And our multiplicative feature says I'm supposed to multiply that by 1,000,000. So 5 times 1,000,000 is 5,000,000. This is going to be 5,000,000 something. All right, now what do we have after that? Well, notice I have this big grouping of symbols with a single bar over all of them. So let's start by looking at what's under the bar. CXXI. That's 100, 2 tens, and a 1, or 121. But I need to multiply that by 1,000 because that's what the bar is telling me to do. So what is 121 times 1,000? Well, that's 121,000, okay? And then what's after that? A C followed by a D. Remember, C is 100, D is 500. And notice what we have here is a smaller number preceding a larger number. So this is where we would use the subtractive feature because we would normally have it the other way around. Rather than write 100 and 500, I'm going to take the smaller number and subtract it from the larger number. 500 minus 100 would be 400. There's no other numerals after that, and so that would be the whole number, 5,121,400. Okay? Moving right along, I want to do this in reverse. So I have these two numbers here, 648. And I'd like to write this in Roman numerals now. So let's think about this for a moment. 600. We do have a symbol for 100. It's C, but I'm not going to write 6 C's here. Because again, the Roman numeral system is devised in such a way that it kind of prevents long strings of the same digit showing up over and over again. What we want to do here is use the fact that not only do we have a symbol for 100, but we also have a symbol for 500. The symbol for 500 is D. Okay? Now 500 is not enough. If I have a 600 here, then this 500 needs to be added to a 100, totaling to 600. That's what that would look like. Okay? Next up, I have a 4 in the tens place. Now 10 is represented by the Roman numeral that looks like an X. But for the number 4, we don't put 4 X's. This is where we would use the subtractive feature. 4 is close to 5, and I have a symbol for 50, because this is in the tens place. So let me say that differently. 40 is close to 50. We have a symbol for 50. It's the letter L. But if we subtract 10 from 50, that would give us the 40 that we want here. And how do you show that using the subtractive feature? You take the smaller number, which is the 10, and then the larger number, which is the 50, that you're taking that 10 away from. So DCXL, that's what this looks like so far. 8 in the ones place. We don't use the subtractive feature for this. The subtractive feature is only used if we're 1 away or 1 below the next symbol. So 4 is 1 below 5, and we have a symbol for that. Or 40 is 1 below 50. 40 is a 10 below 50, I should say it that way. 8 is not 1 below something that we have another symbol for. So I'm going to represent 8 by a 5 and 3 ones. So there's the number 648. Okay? Let's try this with a larger number. 4,006,729. How would we represent this? Well, 4 million, remember when numbers get this big, we use that multiplicative feature. So let's think about the number 4 for a second. 4, we would use our subtractive feature on. 5 minus 1 to get 4. But then to turn that 4 into a 4 million, I use the double bar, which shows that I'm doing that multiplicative feature. So this part takes care of the 4 million. Now what do we have? 6,000. Okay, well, I know that 6,000, I have a symbol for 1,000. It's M, but I don't want to write 6 of those. Remember, you should never really have 6 or even 5 or even 4 of the same symbol in a row. The multiplicative and subtractive features prevent that from being necessary. So how can I use my multiplicative feature here? Well, let's think about what the number 6 looks like. The number 6 is 5 and 1. And then my multiplicative feature says that a single bar over that would represent multiplication by 1,000. So now we have 4,006,000. Let's get the rest of the number out. 700, I would like to think of that as a 500 and 2 100s. That's D, C, C. 20, that's 2 X's. X, X. 9, I don't want to do 9 I's or 9 ones. I'm going to use my subtractive feature and subtract a 1 from a 10 to get 9. That would mean that I write that this way, IX. Okay? Hopefully that makes sense. It really does take practice getting used to this. It's kind of just a different way of thinking about representing numbers. Okay, next thing I want to do is attempt doing subtraction with Roman numerals. Now, this is a little bit difficult because those features, that subtractive and multiplicative feature that we use to kind of make the writing of numbers more efficient, ends up making arithmetic with those numbers more difficult. And our way around that is, for the purpose of addition or subtraction, we undo those features first. In fact, it's also kind of helpful to undo the numbers that are in the middle. So for example, if I have a 5, a symbol for a 5, I might group that up with any other symbols and get rid of it. I'm going to show you what I mean by that. So when you're given a subtraction problem like this, we're actually going to rewrite this entirely. And here's how I'm going to do that. Starting with this guy right here. This is 10 followed by 2 1s. that would be 12. But we're multiplying that by 1,000 because that's what that bar is telling me to do. So what I'm going to do is write this using 12,000 symbols, which are the m's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, normally with Roman numerals, we don't stack them the way that we do with Egyptian numerals, but for the purpose of doing the arithmetic, it's okay to do that, and we'll just make sure our answer is written in the correct form. These C's here are fine the way that they are. I'm not going to do anything with those. 1, 2, 3. Leave those alone. The VI, remember, that's the number 6, and I'm going to get rid of any of those in-between symbols, like 5 or 50 or 500, and instead just write this as 6 I's. 1, 2, 3, 4, 5, 6. Okay, now we're subtracting. And then looking at my second number, I have 2 m's, so that's 2,000. M. I have 1 C, so that's going to be represented by just a C. One thing I didn't really account for here, which I should have left myself some space. I'm actually going to redo this. I wanted to leave some space because I didn't have any 10s here. So let me try this again. We're going to do 12 m's. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3 C's. 1, 2, 3. No X's. That's like having a place value of 0, or a placeholder of a 0 in my tens place. I'm going to just leave space to represent that. And then my 6 I's over here. 1, 2, 3, 4, 5, 6. All right. Now, we'll continue doing what we were doing before. 2 M's, 1 C, so that's 1 100, 3 X's down here, 1, 2, 3, and then 2 1's, 1, 1. And we are subtracting these. Far less efficient way of representing these numbers, but better suited for what we're going to do here, which is subtraction. Now it's going to be very similar to what we did with the Egyptian numerals. So I can cancel things. You know, these 2 1's down here will cancel with 2 of these ones, leaving me with 4 1's. 1, 2, 3, 4. Notice that I don't have any 10s up here to cancel with these 10s. This is where you can do a borrowing technique. So I could borrow one of these hundreds, and that gives me 10 10s. 5, 10. Then we do some canceling. 1, 2, 3. 1, 2, 3. That leaves me with 7 10s. Okay. Then I can do some canceling here. Cancel that with one of these, leaving me with one of my hundreds. Cancel these 2 thousands with 2 of these thousands, leaving me with 1, 2, 3, 4, 5. How many do I have? 1, 2, 3, 4, plus 6. I should have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, even though we've done the subtraction, I know that that's not the right way to write this number in Roman numerals. There's too many symbols showing up. We need to start using some of our features, right? So what is this place value? What is this actually representing right here? Well, this is 10 thousands. That's the number 10,000. And we can use our multiplicative feature to represent that. 10 times 1,000 looks like X with a bar over it. Okay? Now what do we have? C represents 100, and that C is totally fine as it is. So let's write that as just a C. Okay? Now, there's far too many X's here, so how do we use our features to shrink that down a bit? I have 1, 2, 3, 4, 5, 6, 7 of them. So I need a numeral, a Roman numeral that represents 70. And this is where one of those in-between numbers comes in. Let's use our symbol for 50, which is L. That takes care of 5 of those 10s, and then I just need 2 more. 50, 10, and 10, that makes 70. Same thing as this. Finally, 4, we've seen before, we can use our subtractive feature for that and write that this way. And so this is the answer. Notice it's a little bit longer of a process just simply because we had to take these numbers, kind of blow them up, do the subtraction, and then shrink the answer back down again using those multiplicative and subtractive features. Addition can be done in a very similar way, where we, again, blow up the numbers, do the addition, carry if necessary, and then consolidate back down to the simpler representation of that numeral. But instead of showing you an example like that, I'm going to finish things up with an example that appears in the book, because this also introduces some of the technology, if you want to call it that, that Roman merchants would use for addition. They used something called a counting board. And so the idea of a counting board is you represent numbers using little pebbles on a board that has these long grooves next to symbols that are meant to represent. So for example, let's say a Roman merchant wants to calculate 964 plus 286 on a counting board, one of these things. This is done as a 3-step process. They take the first number, 934, and then they represent it using these pebbles. So the number 934, 900 can be thought of as a 504 100ths. So that's where those pebbles would go. This pebble for 500, 4 of these 100s right here. 30 is like 3 tens, 1, 2, 3. 4 is like 4 ones. Now, normally if I was writing that as a Roman numeral, instead of using D followed by 4 C's for my 9, I would do a C followed by an M. That's the subtractive feature. But these counting boards are not capable of representing the subtractive feature. And so we actually use however many pebbles we need to add up to the correct number. But this would be the number 934. Then on the same counting board, but a little bit to the right, we represent the second number using those pebbles. So remember, we're adding 286 here. 200 is like 2 C's, 200s. 80 can be thought of as 50 and 3 tens. There's a 50, 1, 2, 3 tens. 6 can be thought of as a 5 and a 1. So here's a pebble for 5, here's a pebble for 1. Then what we do, we look at the total because it's an addition problem. So we slide all those pebbles together, and if we can simplify it all, we do that. So here's what that looks like. Down here, if I take this 1 and slide it over to these other ones, I'm going to have a total of 5 1s in this groove. But we have a symbol for 5. So I can remove those 5 1 pebbles and add a single 5 pebble up here. That's going to give me 2 5 pebbles in this row right here. But 2 5s is the same thing as 10. So if I use those 2 pebbles to create a 10, I can remove them from the board. Notice that in the final answer, there's nothing left in the 1s, nothing left in the 5s, because we're regrouping. Now I have another 10 up here. So how many 10s do I have when I slide everything over to the left? 1, 2, 3, 4, 5, 6, and then the new one that came from down, all this stuff down here. 7, okay? Which is the same thing as 7D, right? Because these are 7 tens. 70 is better represented by a 50 and 2 tens. So let's take 5 of those pebbles from this row, use them to create another 50 up here, leaving me with just 2 tens. Notice there's 2 tens. However, I already have a 50 pebble, and another 50 pebble will make 100. So let's swap out those 2 50s, add them up here to make 100. Now we have 1, 2, 3, 4, 5, 6, 7 hundreds. If I represent 700 as 500 plus 200, then I can remove 5 of those hundreds pebbles, leaving me with just 2. Notice how we have just 2 here, and create another 500 pebble. But now I have a 500 pebble and another 500 pebble, which adds to 1,000, so I can remove my 500s and just use 1 pebble for the thousands place. Notice it's much more simplified now. So that's 1,220. That's what that number would represent. Now you might look at this and think, wow, that seems like a lot of work for a basic addition problem. And again, it is. This is not meant to be an efficient technique. This is a technique that was used before we had our much more efficient Hindu-Arabic numeral system, where we could do addition vertically without much trouble. Okay? If anything, teaching you these historical numeration systems and doing arithmetic with them is meant to give you an appreciation for what we have now. It's much better what we have now than what they had back then. Another thing worth mentioning is these boards, like the example indicates, were frequently used by merchants, and they would use them all the time. So even though it took me a while to talk through that example, they would get very proficient at this because of how often they would have to do arithmetic this way, and that process that I just talked through would not take them nearly as long as it took us. It would be a very quick process because that's how they were used to doing arithmetic. Okay, like I said, we're not covering the Chinese numeration system that comes after this in the book, so this is where we're going to wrap things up today.